Hi everyone, my name is Ram Vennam. I'm Director of Field Engineering here at Solo. I've been working on the Istio project for around like 5 years now. So before Solo, I was at IBM, also working on Istio. And before that, I was a dev advocate for our Kubernetes service, IBM Cloud Kubernetes service. So I've been in the space for a little while. But now at Solo, I exclusively focus on helping customers adopt service mesh, API gateways, GraphQL, pretty much the whole cloud native networking stack on top of Kubernetes. So today I want to do like a quick talk on like a high level overview of what it means to adopt both Istio and Cilium. What are the overlaps? What are the things to look for? Why there's two. The main focus of this talk is around defense in depth, right? If you read the security overview pages of Istio or Cilium or any other cloud native software that sits on top of Kubernetes, they talk about adopting defense in depth in order to protect against multiple layers of a security attack or a potential security attack. To simplify it down, it pretty much boils down to if one measure of layer is ineffective, whether it's been compromised or misconfigured due to user error or due to an actual attack, there is another layer behind it that can stop that attack. So it doesn't necessarily mean that you need multiple for every different types of attack, but when it makes sense to do it, when if it is in the right space and you're able to do multiple layers of defense measures, you should adopt that pattern, right? So this problem of adopting defensive depth was exacerbated after we started adopting microservices. Or the way to solve that problem is tremendously more challenging now that we have microservices. Simply because you don't have just a single app that you can just put layers of defense around it and call it a day. But now that everything is a pod and you have hundreds and thousands of pods across different zones and data centers and regions and cloud providers, there's not a single solution or a single set of barriers that you can put around any application. Every application is different. Not only that, there's some security measures that it actually makes sense to share that boundary between a set of pods. Meaning every pod's not going to have this full-blown set of security measures around it. Some of the pods, maybe pods in the same namespace, have one security boundary, or pods in a Kubernetes cluster have a different set of boundaries, et cetera. So there's multiple layers. And what makes the problem even worse is that there's different tools that guarantee protection for multiple layers. And there's overlap between these tools. Meaning, it's not like you can break down the defense in depth layers or the OSI stack layers and say, well, this layer is this product, this layer is this product. It's not quite so simple like that. Every layer is protected by a different set of tools, and a single tool can protect multiple layers. So that's why defense in depth is important, so that you have multiple ways of protecting against a potential attack. So first, we're going to drill down to Istio, and then we're going to talk about Cilium and talk about what the overlaps are and how they're different in achieving what they do. Right? So this diagram is straight from Istio.io security concepts page. And it talks about how Istio provides a full comprehensive set of layers around your Kubernetes pod to give you security. There's the outer perimeter layer. So this is the ingress gateway or the egress gateway. This is where you attach things like your WAF, your DLP, your user authentication, your request authorization, all the traffic that's coming into your network. Who's even able to come into the network, and what are the authentication and authorization rules you want to apply on top of it to filter that traffic. So that's one layer. The next layer is pod-to-pod encryption, right? So this is to prevent against man-in-the-middle attacks. You don't want to be able to sniff the traffic in your cluster and see who's talking to what are the headers, what is the data, et cetera. So you cannot trust your Kubernetes network, is essentially what it boils down to. And then Istio offers you encryption from pod to pod. So from ingress gateway to your first front-end pod, there's encryption. From that pod to another pod, there's encryption, and so on. So that is encryption. So that would be like, point in the middle. You probably can't see this one, so I'll just kind of talk about it. And then after that, there's strong identity that Istio associates with each individual application. And that's really where the focus of this talk is going to be on, is how that identity is established. As a quick overview, again, this diagram is from Istio.io. The way identity is established in Istio is whenever there's a new pod that comes up in your cluster, that pod, there's an init container that runs in that pod, and it uses the Kubernetes service account token and talks to the Istio control plane, where it's the Citadel portion of the Istio control plane, which acts as a CA, and exchanges it for an identity certificate. So it's a strong X509 certificate that has its identity information directly built into that cert. Every single pod has this cert that's associated with it. So now when one pod wants to talk to another pod, the envoy, the sidecar of that pod, will use that certificate to say, this is who I am, and they'll talk to another pod, and the envoy on that server pod will also have a certificate, so they'll do a mutual TLS handshake, they'll agree on who each other is, and then establish an encryption, and then they'll start talking to one another. This is also how authorization policies in Istio are built upon this principle. So with Istio authorization policies, when you say, I want an authorization policy that says this particular service account is allowed to talk to this application or an application with this set of labels, what that translates to is envoy configuration that is a filter for exactly what that identity is, what that spiffy ID is. So envoy in every single pod knows what identity is envoy in every pod knows which identity is allowed to talk to it. So that's how it's able to say, yep, you're allowed to talk to me. It says here that you can talk on port 9080. This is the path you can talk on, etc. So that's how it's able to establish. So the key takeaways from that side is that the enforcement point is happening on the envoy on the server level. So if user pod wants to talk to the preferences pod, the enforcement point is happening at the envoy on the preferences pod. So basically on the server side, and it's using the strong identity to build this filter. But what if the certs are compromised? Meaning, this doesn't happen. Hopefully this shouldn't happen often. But what if that certificate information is compromised for whatever reason? Maybe you've lost track of keeping your CA secure, or you have a vulnerability in one of your pods that's extracting that information, right? So you need to prevent against things like this. If a particular certificate information for a given pod is lost, that means another pod can act like the same pod and talk to whoever that pod was originally intended to. Can all pods talk to one another now? No, it's only that one certificate information for that one identity is now compromised. Another big reason why users adopt Istio is that they want to be able to enforce ingress and egress policies. So let's focus on egress, for example. If you want to say that you don't want applications talking to an external endpoint without explicit declaration on what those endpoints are, that is also enforced by Envoy in that particular pod. So it's also enforced by that proxy. So again, what happens if the application is somehow able to bypass that proxy, right? We're relying on these IP tables rules or CNI to redirect all traffic to the proxy, but what if you find a way to go around the proxy? What if the application developer doesn't deploy the proxy because you don't have the proper checks in place to prevent against that? So again, the point is that you're relying on that sidecar to do that logic, and there is a potential way where you can bypass that sidecar. So that's where things like having that second layer really come into play. So let's talk about Cilium for a second. So Cilium is a CNI, right? So at the core of it, it watches all pods that are coming up in the cluster. It's able to give them an IP address. It's able to keep track of who's allowed to talk to who, and it's able to maintain that network overlay so that communication between one another is basically being declared and created by Cilium. If you look at the Cilium set of features that it offers, it kind of looks very similar to the Istio set of features that it offers, right? It's identity aware security, advanced network policies, multi-cluster connectivity, service load balancing, etc. So how is it able to do seemingly something similar? And I think, again, it comes back to how it's doing what it's doing, and that comes back to identity. So with Cilium, whenever a new pod comes up in the cluster, it watches for that pod and it extracts information about that pod, metadata about that pod. Things like what are the labels that the pod has on it, what is the service account that it was used to spin up the pod, and then what is its IP address. And it takes this information and gives it an identity, but that identity it's just like an integer. It's just a number that it gives it and says, okay, this is this pod. It's not a certificate. It's not like a strong cryptographic identity. There's no certificates involved, right? So it is possible to do things like to have like network spoofing, where another pod can maybe take that same IP address that was previously assigned to this and trick the system. Or if there's a lot of churn in the cluster, like a lot of pods coming up and down, it is possible that a pod goes down, another pod comes up with the same IP address, and then the Cilium agent did not pick up this change fast enough and push its identity to all the various Cilium agents. The way it keeps track of all this identity is that on every single node there's a Cilium agent, and that agent is what is keeping track of all the new pods that are coming up, assigning an identity to it, and it has to share that information with the other agents, the other nodes, the agents that are running in the other nodes in that cluster. So there is this state that has to be constructed. So really, like, there could be some vulnerabilities in the time it takes to keep all this stuff in sync, and also the part about it not being a strong cryptographic identity. So the way you would enforce a Cilium network policy at a layer 3, layer 4, layer 3 being IP, layer 4 being port, for example, is you can use those match labels to identify which pod you want to talk from, which pod you want to talk to, and then you can say that communication is allowed. So if you create just a layer 3, layer 4 policy, then the enforcement point is basically that Cilium eBPF layer that connects the two pieces together. So there's no sidecar involved in this, but it's at the CNI layer. So that's a pretty good way for you to basically cut off that communication. Cilium also has layer 7 policy. So meaning you can add stuff like HTTP verbs or paths or things like regular expression, stuff that's in the request metadata that you want this policy to parse and then enforce it. There's no way to do that with eBPF directly, because you need something like a layer 7 parser like Envoy to be able to understand that request. So the way Cilium accomplishes that is that it spins up a brand new Envoy process in the Cilium agent pod, and then traffic gets redirected to that pod. So you can probably already tell, like, okay, there's a single Envoy pod that's being shared for all traffic that's coming through this agent. So then you start having multi-tenancy problems. We talked about that in the ambient workshop a little earlier today, where you have to be careful about how you do multi-tenancy in Envoy. You can have noisy neighbor problems because you can extend envoys to do complex, expensive operations that you don't want other pods in the network, other requests that are coming in, to be impacted by that. So you don't quite have this independent level of tenancy. And there's also identity, right? Like, you don't want a single envoy to be able to manage traffic coming from all identities coming in and out of your network. So we think that this model, while this is a fallback that can get you there, at the end of the day, this is Envoy doing layer 7 stuff. This is Istio's expertise. Leave this to Istio. Leave layer 7 stuff to Istio. There's already an Istio control plane. There's already an Istio Envoy. Istio's figured out many of these problems that you would have with this model. So what we do with Glue is kind of help you abstract away all these implementation details. Whether you have to create a network policy or an Istio authorization policy, or you need both, that's something that if you didn't have a management plane, you would have to figure out on a per application basis. So again, it's a lot of potential areas for you to make make a mistake in the system and misconfigure it or not even configure it from the beginning. You're leaving it up to your developers. That's where something like a management plane that can, or like this Glue platform, that knows about all the applications in your set of clusters, and it's able to dynamically determine where is this application that you're trying to talk to, is there Cilium installed, is there Istio installed, and it's able to lay down the right policies. It can intelligently determine based on what's installed, what you have declared in your Kubernetes, your deployment, your container ports, your service definitions. We can get you most of the way there in a zero trust posture. So that's where a management plane that knows your entire environment holistically gives you that central place of intelligently being able to create policies. And one big construct that we use to be able to do that are what's called workspaces. Think of workspace as just a set of namespaces, a grouping of namespaces across clusters. You can say like this namespace in this cluster and these two namespaces and this other namespace in this third cluster are one team. That is how you declare a single workspace, right? And then you can create multiple workspaces like that. So now what you've given the Glue platform is information about your organizational boundaries. From that information, Glue can automatically determine what the boundaries are, what the Istio authorization policies should look like, what the network policies should look like. So it can lay down this defense in depth. It can lay down multiple layers of policy automatically for you. And with using construct like exports and imports, you can tweak it appropriately, or you can take over full control if you choose to. You need to do that. So that's what the management plane does is, we hope to give you a single place for you to apply this policy or this workspace construct to group your applications together. And then the management plane automatically determine you have this version of Cilium installed on this cluster, and you have Istio and Cilium installed on this other cluster, and be able to push those policies automatically for you. If you take one of the applications and move it from one cluster to another cluster, the management plane knows that, and it's able to update the policy automatically. So it's just one more way that your life is simpler or is simplified by not having to create those policies manually. And then best of all, it goes and aggregates all the metrics information that Cilium collects, that the sidecars collect, that Ambient collects, pull it all back to the management plane, and give you a unified service graph so you can see exactly how traffic is flowing within your entire system holistically across all your environments. I know that was a lot of information that I kind of like covered at a high level. Solo does have deeper dive talks that we do on our YouTube channel. So if you go to YouTube and type Cilium and Istio, you would get a result like this, where experts like Lynn and Yuval and Eitan and Scott and Christian go into this in much more details than I did. I think I covered like 3 different big sections of defense in depth, but if you will go watch these videos, you'll get it in much more detail. So with that, I want to say thank you, and if you have any questions, you can reach out to me at ram@solo.io or on our Slack channel. Thank you.